So this lesson is about the key concepts of energy, and it's important to know these key concepts before we look into energy in more detail in later lessons. So by the end of this lesson you should understand why energy is one of those key concepts in science that we need to know about. You should understand ideas about stores and transfers to explain what the energy actually does, and also understand why accounting for the energy transfers is a really useful idea. So before we start, you need to have the energy equations written down, or at least in your head. So what I would say is pause the video now and see if you can remember the equations for each of these types of energy, and don't forget the units. So these are the energy equations that you're going to need to know for your GCSE. The ones in light blue are ones that you will need to remember, and the ones in the purple are ones that they will give you on your exam paper, and they'll give you those in the equation sheet. So pause the video now and make sure you've got these written down before you start studying this unit. So it's important that you know what the different types of energy are, and this is a really good mnemonic in order for you to try to remember them. Every clever good pupil knows that spiders have 8 legs. Nice. So pause the video again here and see if you can remember what each of those represents. So our types of energy are electrical, which you can find in electrical storms, and obviously everything you plug in uses electrical energy. Chemical energy, which can be found in food and also in batteries. Gravitational potential energy, and now that's any energy that is stored in an object due to its height off the ground, so books on a shelf. Kinetic energy is any type of movement energy, so whenever something is moving it will have kinetic energy. Sound energy, fairly obvious, probably what you're listening to from your speakers at the moment is sound energy. Thermal energy, or heat, which is anything that produces thermal energy, is like fires, etc. Elastic potential is any energy due to the stretch in a spring or the stretch in an elastic band. Light energy, again an obvious one, it's the energy that comes from the sun but also from light bulbs. And nuclear energy is, again, it's the energy from nuclear power. So energy is a concept in science which is fundamental, and it's because energy is what makes things happen. So we talk about types of energy, but often it's easier to think about energy being stored. So when a book is on a shelf, it has a store of gravitational potential energy. When a spring is stretched, that's going to have a store of elastic potential energy. And one of the fundamentally important things with science is that energy cannot be created or destroyed, it can only be transferred. So let's have a look at an example of how energy is transferred. So if you were walking along on a dark road at night, you might have a torch to light your way. Now in that torch you would have some batteries. And batteries have chemical energy, so our input energy would be chemical. And our output energy would be the light, and that's useful energy. Now, in between that, the chemical energy will go into an electrical circuit. And so we have chemical energy is transferred into light energy via electrical energy. And some of that energy, but not all of it, comes out as light. Some of it will be lost to the environment as heat energy. And so that's a typical energy transfer. So hopefully that's given you a basic understanding of the key concepts involved in energy and why it's such a fundamental thing for science, and that energy cannot be created or destroyed, and that we have to be able to account for that energy. Hopefully you've got all of the equations down as well. If not, go back over, write down the equations. You'll need those for the rest of the unit that we're going to be studying when we study energy transfers.